Let's do an example that's similar to the last one, where we'll have a transformation of an exponential function. In this case, we have 3 times 1/2 to the x. But in this case, we have, as we see, a stretch. And we'll go ahead and talk about how this affects the graph, and specifically the domain, the range, and the asymptote. First, let's talk about how to identify that this is a stretch. So we'll need the original function that is being transformed. That is 1/2 to the x. And so our transformation, g of x, is 3 times f of x. You see, if you replace this f of x with 1/2 to the x power, we get the expression that is in our function. So g of x is a vertical stretch by a factor of 3. And let's go ahead and graph this. First, we'll graph our original function, 1/2 to the x. And because we've done some graphs, you'll find that you'll get quicker and quicker graphing these. So 1, 2, 1, 2, -1, -2. And I'm going to need 4 as well. In the graph of 1/2 to the x, at -2, it's 4, -1, it's 2. Now remember, b to the x goes through the point 0, 1 for every b. So in particular, for the graph of 1/2 to the x, that's going to go through the point 0, 1, 1, 1/2, and then 2, 4th, and we can go ahead and connect these. So this is our original graph, 1/2 to the x. So we'll take each one of these points and we will vertically stretch it by a factor of 3. We'll multiply the y values by 3. And forgot to put my scaling and my axes labels, so I'll do that. And for this leftmost point, I'm just simply not going to be able to fit it on the screen, and that's okay, it happens. So for this point -1, 2, 2 times 3 would be 6, so the y value would jump up to 6. At 0, 1, we multiply that by 3. Gets a little trickier with the fractions. I have 1, 1/2, multiply that by 3, and I get to the point, or the y value of 3/2. At 2, 1/4, you multiply that by 3, you get the 2, 3/4. And we'll go ahead and connect these. It'll look something like this. And now notice that as opposed to shifting the y values, which will take y values that are very close to the x-axis and move them away, stretching also moves the y values away from the x-axis, but not very far if the y value is very small. So if you have something like y equals 0.0001, then multiplying that by 3, or in other words, doing a vertical stretch by a factor of 3, will give you something farther away, but still very close to the x-axis. So that's why I'm drawing my graph in such a way that it still gets very close to the x-axis. One thing that is important to note here is this graph goes through the point 0, 3. If you have a stretch or a compression of some exponential, so that you know your graph is of the form a times b to the x, then this intercept here can tell you what the value of a is, because when you plug in 0 for x, you get a, and so this here should be the y-intercept. So notice that the y-intercept, the y value of the y-intercept is 3. That matches my vertical stretch, and that's going to happen every time. Or at least every time there's only a vertical stretch. If you have a stretch and a shift, then that may change, but if there's only a stretch or compression, then the y-intercept is going to match that value that corresponds to the stretch or compression. Let's go through the other things that are asked for, so the domain, range, and asymptote. So what x values are we allowed to plug in to our transformed function g of x and get a result? Well, every x value. We can plug in any x value to 3 times 1/2 to the x and get a result. So that tells us that the domain is all real numbers. So we can say the domain is -infinity, infinity. What about the range? Well, we still have this fact that if we draw a horizontal line anywhere, as long as it's above the x-axis, we get an intersection with our graph. If it's on the x-axis, we do not get an intersection, and if it's below the x-axis, we do not get an intersection. And what that tells us is that the y values that are achieved by this transformation is all the y values bigger than 0. And that's precisely what the range is. It's all y values bigger than 0. And finally, as to the horizontal asymptote here, we see the horizontal asymptote for 1/2 to the x is y equals 0, as usual. And if we ask ourselves what's the horizontal asymptote for 3 times 1/2 to the x, well, the y values of our transformed function are getting very close to the x-axis as x gets large. And so that means that our horizontal asymptote is still going to be y equals 0. So what we see here is if we have a stretch or compression, it's actually not going to change any of the domain, range, or horizontal asymptote. What it will change is the y-intercept here, and of course it's going to change the shape of the graph. It's going to stretch or compress it.